In this video, we're going to look at one more example of translating contextual problems into inequalities. So let's read through the problem. The amount of time Ayana spent running is strictly between 43 and 67 minutes. And now I'm going to highlight the is strictly between in green because that is our connective. Okay. So notice this one is a little bit different. This is actually something we're going to call a double inequality. Okay, so first let's define our variable. And notice there's one variable here, and it's the amount of time Ayana spent running. So let's define that. I will define it as capital A, the amount of time Ayana spent running. And notice we don't have a unit of measure. We're measuring time, but notice the two numbers we're given are labeled with minutes, so we're going to measure this in minutes. Okay. Now let's talk about the words is strictly between. So first let's just talk about is between without the strictly. So there's a reason I have the strictly there, and we'll talk about it in just a second. But if I said I am, here's my house, here's my school, house, school. If I said I'm between home and school, say this is the road, you would think that I am somewhere in between. If I called you and said, where are you? Oh, I'm between home and school. You'd probably think I was on my way to school from home or vice versa. And typically the word between we think of in the middle, not including these endpoints. So it'd be kind of silly for me to say I'm between home and school if I was actually at home. Okay. But in mathematics, it can be a little bit more complicated. What does between really mean? How are we going to translate that? And there's not really a consensus on how to do so. So when we talk about between, okay, I'm just going to do a simple example. 6 is between 5 and 7. Okay. Well, that would mean, we're going to say that that means 5 is less than or equal to 6 is less than or equal to 7. Okay, so even though this between idea seems to mean that it doesn't include the endpoints, these two boundary values, we're going to say it does. And if we definitely do not want that to be the case, we're going to use the word strictly between. So remember, strictly, we said, means that it excludes the possibility of being equal to. So if I say 6 is strictly between 5 and 7, we will write 5 is less than 6 is less than 7, and we won't allow for inequalities. So I know these are numbers. Both of these are actually true. The equal signs aren't necessary because 6 is between 5 and 7 and doesn't equal them. But now that we're dealing with variables, it can be a little bit different, okay, or a little bit harder to decide. So when we say strictly between, we're going to say that that means that it's a strict inequality where it can't be equal to either of the endpoints. And now notice between, and you should see this coming from what I wrote here, means that we'll write this as two separate inequalities. Both of the following are true. Okay, the amount of time she spent running is greater than 43 minutes, and the amount of time she spent running is strictly less than 67 minutes. So both of these are true. Okay, but we want to make a single symbolic inequality statement, and we're going to use this structure down here. So we're going to actually put the A right in between. Okay. Notice that here I wrote A is greater than 43. Okay. 43 is less than 67 though. So I want to put 43 on the left And instead of writing A is greater than 43, I'm going to write 43 is less than A. And now I'm going to use this part. A is less than 67. So notice how this puts A between 43 and 67. And in this case, strictly between 43 and 67. Okay? And in general, if you have numbers more than 2 expressions, so here we have 3 expressions, all of your inequality symbols should be pointing in the same way. So notice, just like we did before, I could reverse this order and say 67 is greater than A, which is greater than 43. Okay? So notice all of my inequality symbols are going in the same order. Now I'm going to write something in red, which is wrong. Okay, now red, I'm going to put a big X through it because my inequality symbols are not going in the same direction. And this actually says that 67 is less than 43, so you can follow the string of inequalities across. It says that 43 would be also less than 67. That part's actually true, but the whole statement as a whole is not true. So if you ever have a double inequality, okay, where you're using this between idea, you have a number bounded on a variable bounded on 2 sides by 2 numbers, your inequality symbols need to go in the same direction. And typically, we prefer this one, okay? And if you solve an inequality and you get an answer like that, like in this form, we'd probably rewrite it in this form, even though this is equivalent. Okay, so now this is our inequality. Now let's list 2 values of the variable that make the inequality true. Okay, so this should be pretty easy. We want to pick 2 numbers between 43 and 67, and they should not equal 43 or 67. So I'm going to say A equals, how about she spent 45 minutes running? Or it's possible she spent, you can even say a fraction of a minute, 66.5 minutes running. Okay, both of those values are between 43 and 67, strictly. Okay, 2 values that make the inequality false. Well, if she ran less than 43 minutes, so say 15 minutes, okay, 15 is less than 67, but 15 is not greater than 43. Okay. If we said something greater than 67, like 70 minutes, we'd have the other problem where 70 is greater than 43, but it is not less than 67. And let's just write those down real quick. So these are the ones that are false. I want you to see the structure instead of just saying it. 43 is less than 15 is less than 67. That was our first false value, and we also said 43 is less than 70 is less than 67. So notice part of these inequalities are true. Okay, 15 is less than 67, that's true, but 15 is not greater than 43. Okay, and the whole string of the inequality must be true. So that's why this is false. Okay, so here 43 is less than 70, this part is true, but 70 is not less than 67, so this part is false. That means the entire inequality is false. Okay, so that's our last example of contextual problems, writing them into inequalities, and now we're going to start building and construct inequalities with the purpose of solving them.